Here we go. So bell work today, obviously a representation of free response questions and how they would set up and what we need to do. Okay, the first one says, they gave me this equation, n of t. The number of fish in a pond at time t years is modeled by this equation, where f is a continuous function and f of 0 is equal to 80. Is the function n continuous at t equals 8? Justify your answer. So as you read that question, what's the most important word in that question? Continuous. I want to know, am I continuous? What has to be true in order for a function to be continuous? Left, right, and value. The limit from the left, the limit from the right, and the value. Or in other words, the limit has to exist, the value has to exist, and the limit has to equal the value. That's it. That's what we're trying to show here. The most important thing on this problem is setup. Okay, so we're going to find the limit. At what value do I care about this limit? 8. We're going to find the limit as x approaches 8 from the left. Which equation are we going to use if we're doing the limit as x approaches 8 from the left? This guy right here. That's 8 from the left, so that's the equation we're using. So I'm just going to write that down. 25t plus 150. That's the limit from the left. Our job is to decide, is that equal to? So I make up this little symbol of an equal sign with a question mark above it because we're trying to decide. Is that equal to the middle? Well, what's the middle going to be? Which equation am I using to do the middle? This one, right? I want to be equal to 8. So if I want to be equal to 8, I'm using this equation right here. So I'm trying to see, is that equal to n of 8, which is that equation? And I want to know, is that equal to which equation from there? The third one. The limit as x approaches 8 from the right. Oh, what numbers are bigger than 8? Oh, it's this equation right here. 200 plus 80t all over 2 plus 0.05t. The good news is this isn't a question. I know that those two are equal to each other because they're the same equation. That is the key to success, having a correct setup. Okay, if I were doing it maybe a little bit better instead of n of 8, maybe I would write this, but I just wanted to make it clear. Maybe just take that second equation and show that I'm plugging in, or that third equation and show that I'm plugging in 8, but same difference. Limit from the left, the middle, and the right, they all need to be equal to each other. How do I find the limit from the left? Plug in. I take 8, I plug it in. 25 times 8 is 200. 200 plus 150 is 350. Anybody plug 8 into that other equation? Guess what you get? 350. And if that's 350, I know that's 350. All three of them are equal to each other. Boom. Are we continuous? Yes or no? Yeah, I'm continuous. I'm just going to state that now. Okay? Am I continuous? Yes. Continuous at t equals 8 because the limit as x approaches 8 of n of t was equal to n of 8, which was equal to 350. I only had to write the limit once here because by writing this, it's saying that the left and right are already equal to each other. I did that by showing it over here. This is just as important as my conclusion. Writing this limit notation with the answer and this with the answer, and then saying, yeah, the limit from the left and right are equal to each other. The value's equal, and they're all equal to 350. So yes, I'm continuous at that spot. Questions on how I showed continuity there. Limit from the left, limit from the right, and the value all need to be equal to each other. We good? Next one. The function n is continuous at 6. Is there a time between 0 and 6 at which n of t is equal to 250? Justify your answer. So is there a time? That is the question. I want to know, is there a time where my value is equal to 250? Is there anything we've done all year where we were trying to decide, is there going to be a time where this is true? on, and it's going to be equal to a value. This is an IVT question. You're trying to decide, am I going to hit a value? That is IVT all day long. Okay? This is IVT. In order to do IVT, what must I state? Or what do I need to know? Yeah, you were saying all the right things. We need some endpoints though, right? We've got an interval. The interval is from 0 to 6. What am I going to do? Plug in 0 and 6. I'm plugging in 0. I'm plugging in 6. What do I get if I plug in 0? 80. It's f of t. They don't tell me there, but they tell me right there. F of 0 is 80, so good for that. What do I get which equation am I plugging 6 into? The middle one, because, 6 is equal to t, so I'm plugging into that one. We already did that. Or no, we didn't. If I plug in 6, 25 times 6 is 150 plus 150, I get 300. Based off of that, am I ever going to hit 250? Yeah, I hit 0, I hit 300, I'm going to hit 250. That's guaranteed. We need to state that. So remember, there are 5 things that you have to state to do IVT. Brainstorm those with your neighbor real quick. See if you can write a sentence. Go. Let's see if we can Frankenstein a sentence together. Pulling different parts. Will, what's something you said? N of t. So I'm going to say since. N of t is continuous. And we know that because it stated it. Boom. That is one thing you have to state. You have to state continuity. Jesse, what else did you put? By IVT. We have to say the thing we're using. So by IVT. Boom. Got 2. What else, Max? On the interval. On the interval 0 to 6. Great. There's the next thing I needed, which was an interval. Okay. I'm going to go ahead and just restate the sentence. Okay. Or restate what I'm trying to find. N of t must equal 250 because, and I'm just restating it just that way it's an actual sentence. What else do I need here? 2 more things I need. I need the values. So because I'm going to just say f of 0 is 80 and f of 6 is 300. I'm just stating those endpoints. I should say not f. Sorry, I should say n. N of 0 is 80 and n of 6 is 300. I needed my endpoints. What is the last thing I got to show in order to do IVT? That it's in between. Must because of that, because those are my endpoints, and n of 0 is less than 250 is less than n of 6. That 250 falls in between. You got to say it's continuous. You got to say IVT. You got to say the interval. You've got to say the endpoints. And then you've got to go ahead and say that my value that I'm looking for is between those 2 endpoints. Questions on something we did on that one? IVT question. Good continuity question. Just things that definitely could pop up when you do a free response question. All right, then let's pull out our notes from yesterday. We're on our last section here. Okay. By the time we get done with today, I will have covered every single topic that we've covered in calculus. That's a lot of stuff, but we've done every single one by the time we get done today. Okay? There's a couple things I'm not going to talk about explicitly. Like I'm not talking about extreme value theorem. We've done that one very recently on our last test. I'm not going to talk about optimization. We did that very recently on our last test. Neither of them are as important as the rest of the stuff. That's why I'm not spending as much time on them. Last one's L'Hopital's rule, an important one, but we did that with limits. Okay, that was part of our limits value things we did last Thursday. Let's start off with MVT. MVT and IVT. So talking about IVT, quickly with your neighbor. Say it as simple as possible. What does IVT state? Talk to each other. What does IVT state? Go. It's so quiet because you can all do it telepathically. That's great. I'm glad you have that powers. What has to be true in order for me to talk about IVT? You better say continuous. If you don't say continuous, you're not telling the whole story. You got to be continuous. That's important. Okay? When I think IVT, I think of the simplest statement I can. Okay? And it's going to help me understand. At 2, I was 3 feet tall. At 18, I was 6 feet tall. Was I ever 5 feet tall? Was I ever 5 feet tall during that time interval? Yeah, it's guaranteed. Okay? That statement is IVT explained. We have endpoints. We have a time interval. We said it's continuous because height is continuous. And we said 5 feet, which is between my two ending points. I've stated everything I need for IVT by talking through that. And so if you can remember that little situation, it'll help you out in everything else you've done. Okay? Just drawing a graphical representation of that. You've got a point. You've got another point. Can I connect those 2 points without going through that number or without going through that line right there? If this is 5 feet tall, there is no way to get from there to there without crossing it somewhere. You have to cross it as long as I'm continuous. If I'm continuous, I've got to cross that. That is IVT. Questions with IVT? Let's have that same discussion with our neighbor. Let's talk about MVT. What needs to be true and what does it say? Go. If I'm talking about MVT, what has to be true if I'm talking about MVT? You have to be differentiable because you're talking about derivatives. So if you're talking about derivatives, you better be differentiable. Okay, so that thing has to be true. The simplest way possible, what is mean value? What does the word mean mean? Average. So just hearing the M of mean, oh yeah, the average rate of change. What has to be true about that average rate of change? It must equal the instantaneous rate of change, or in better language, must even equal the derivative. I like instantaneous rate of change, but you don't always remember what that means. It has to equal the derivative. The average rate of change has to be equal to the derivative. Visually, here's what it's describing. You've got a graph. You got 2 points on that graph. Okay? This is the average rate of change. It's the slope between 2 points. Is there anywhere in between those 2 endpoints? So we're talking like on this part of the graph. Is there anywhere on this part of the graph in between those 2 endpoints where the slope of the tangent line, where the derivative would be equal to that purple line? Yeah. I was looking through old AP exams because that's what I do in my free time. Okay? There was a question recently that asked this. How many times on this interval would the slope be equal to the average rate of change? It would be 2. There's one spot right there, and there would be one spot right there. Okay, there are 2 different spots where the average rate of change would equal the instantaneous rate of change, which is guaranteed by mean value theorem. You could, remember to find that, you would just take the derivative and set it equal to the average rate of change. I think it's easier to calculate than it is to look at a graph. The one that I was thinking about, it was a calculator question, and you just had to look at the graph and figure that out. It's a little bit different. Questions there? Let's talk about algebraic applications of derivatives. So normally when we're talking about derivatives, we are describing extrema in some capacity. Remember, extrema is just a fancy word for maxes and mins. There are 2 places. There are 2 places where extrema can happen. Where's one place extrema can happen? Endpoints would be one of them. We want to look at endpoints for extrema. The other place is critical points. We can say that pretty well, but often we forget what a critical point is. What is a critical point? It's two different things. Where the derivative equals 0, that is one thing. Or when the derivative is undefined. That is where a critical point happens. When the derivative is 0 or undefined, that is what I'm thinking about. Okay, right below that it says on what interval is that function decreasing? Work with your neighbor. Answer that question. Go. We are trying to figure out where the function is decreasing. So Jacob, what do I need to do here if I want to figure out when it's decreasing? Yeah, we need to find that derivative. What is your derivative going to be here? Wonderful. There's his derivative. Once he finds his derivative, he's going to set that thing equal to 0. I'm sorry, minus 5. He said minus 5. I put the x in there. We take that derivative, we set it equal to 0, and we're going to solve. So we need to factor here. Two numbers multiply to get me 5, so x plus 5 and x minus 1. So x is obviously going to be negative 5 and positive 1. Once I've done that, Michael, what can I do next? Well, if we plug it into the derivative, I know what those answers are going to be. It's going to be 0 because we just solved that. So the next thing we got to do is do that sign chart. We are going to plug stuff into the derivative. You're correct. We want to look at that sign chart, though. Okay? This sign chart, f prime of x, what two numbers am I putting on there? Negative 5 and 1. If I had endpoints, I'd put them, but I don't have them, so I don't need them. So negative 5 and 1. Then I'm picking numbers, like pick the number 0. What am I going to plug 0 into? The derivative. It's an f prime sign chart, so I'm plugging 0 in there. If I plug 0 into x plus 5, oh, that's positive. If I plug in 0 there, it would be negative. Positive times a negative is a negative. Pick a number bigger than 1, like 10 billion. 10 billion plus 5 would be positive. 10 billion minus 1 would be positive. You multiply them together, get you positive. We could do negative numbers and do the same thing. That would be positive. So the question was, when am I decreasing? Alana, when am I going to be decreasing here? Negative 5 to 1. How do you know that's when I'm decreasing here? Yep, f prime is negative means that f is decreasing. Okay, so since f prime is negative, here we can tell that, boom, there is my answer, is negative 5 to 1. Questions there? Let's look at the second one. If f double prime equals that guy, then the graph of f has a point of inflection when x is equal to blank. Points of inflection, we should be pretty good. This question you can do without really any work. If you just are smart enough, you can look at this question and be like, boom, I got my two answers. Okay? When do points of inflection happen? When the second derivative changes signs. Everybody agree with me on that? When concavity changes signs, when the second derivative changes signs. So we could put this on an f double prime sign chart. I would put x is equal to 1. X is equal to 4. And x is equal to negative 2. Those are the numbers I would get. I just took those, set them equal to 0. Right now, you should know when the second derivative doesn't change signs. At which one of those three values am I not going to change signs? At 4. Why not, Cannon? It's squared. If you're squared, you're not going to change signs. Because if you plug in numbers bigger than that or less than that, it's always going to be positive because I'm squaring it. Okay, so I know what the answers are. The answers are negative 2 and 1, and I didn't have to do really any math. You can double check yourself there. Okay, if I plugged in the number 0, if I plug in 0 here, that would be negative. That would be positive. Negative times a positive would be a negative. Okay, I plug in a number bigger, it'd be positive, it'd be positive, it'd be positive out there. You could check it, but if you're smart enough and you're thinking your way through it, that one should be a really easy question. The only two places where it changes signs are at negative 2 and 1. It would not change signs at 4. Questions there? Even and odd exponents is the thing you're looking for. Yep. Fill in that table with your neighbor. Go. How did you do? As I look at that, there are my answers. Okay, hopefully you should know all of those. The only one that I think you ever struggle with is that last one, so I kind of did it quickly, and you could tell pretty quickly from that. Inflection points. An inflection point happens when the second derivative changes signs. Okay, so when the second derivative changes signs, what am I looking for on f prime if we're talking about inflection points? F prime what? Extrema. Relative extrema. Some people I heard say changes slope signs. That's fine. You could say it changes from increasing to decreasing or decreasing to increasing. That's fine. The easiest way to say it is relative extrema. Okay. Given that, let's look up here. So we've got this graph. It is an F prime graph. Okay, this is F prime. Label it, double label it. Okay, we're going to assume that these points go on forever and then they don't just stop. Try to answer those 4 questions with your neighbor. Go. Point of inflection. This is an F prime graph. So what am I looking for on this F prime graph? Max Harris, to decide if I have a point of inflection. F prime has extrema. I think the easiest way to do any of these questions is to answer it in terms of what you're given first before you do the answer. Like the justification before the other part. What were your answers here, Max? 0.64 and 1. Yep, those are the 3 spots. 1, 2, 3. Those 3 spots are when F prime has extrema. F is increasing. Taylor, what are we looking for if F is increasing on an F prime graph? Where F prime is positive. Good. When is F prime positive on this thing? Yeah, sorry. Yep, 0 to 0.4. Good. Right there to right there. That's the only time when I'm above the x-axis. Emma, next one is when am I concave down? What are we looking for on this F prime graph to talk about being concave down? When F prime is decreasing. Write it first so you see it. From when to when am I decreasing? 0.17 to 0.64 and then 1 to infinity. Yep. Those 2 and then 1 to infinity because we're assuming that thing goes on forever. Okay. Last one. When does F have a maximum? What are we looking for on this graph, on this F prime graph, if I want to know when F has a maximum? Isabella, what do you think on that one? F prime changes from positive to negative. When F prime changes from positive to negative. Where on this graph, Isabella, did I change from positive to negative? At 0.4. X is equal to 0.4. Questions with something we did today?